friends. Hope you are all doing well. Today we are going to derive the relation of all the resistors in series. So, what is the today's derivation? So, R equivalent is equal to R1 plus R2 plus R3. We have to prove this thing. So, this is to prove. We know like this is actually a series circuit. The series circuit is the one in which there is a single path for the current to flow. So for example, this is the actual path for the current to flow. So it means the current passing through each resistor would be same. Now if we write down the Ohm's law, so according to the Ohm's law, we know like V is equal to IR. So we can simply write V total is equal to current total times R total. So the EMF here is considered to be V total. The total current of the circuit is known as I total, and if we write the voltages across the respective resistors, so this is V1, V2, V3. These are the voltages about the across the respective resistors. So we would simply say like we know in a series circuit the total voltage is equal to the voltage across each and every resistor. So V1 plus V2 plus V3 is equal to the total voltage. So according to the formula that we used here, so can I say I total? I total is the I equivalent as well. So I total times R total is equal to I total times R1 because this is the current which is passing through each and every resistor irrespective of whatever the value of the resistor is. So I total times R1, I total times R2 plus I total times R3. I can take IT as common through each equation. So I can simply cancel out I total and I total from both sides. And what do I am getting now is R total equals R1 plus R2 plus R3. This is equivalent resistance which is equal to R1 plus R2 plus R3. So hence we have proved this relation. Thanks for listening. Like, subscribe and share.